Let's study effectively with Miss ICT Skill Builder.
Welcome to this explainer. Today, we're going to crack one of the most fascinating everyday mysteries of our modern lives. We are going to become digital detectives. You see, we click, we scroll, and we tap all day long. But right beneath the surface of your screen, an absolutely thrilling, incredibly complex investigation takes place every single time you want to look at something online. So, let's dive right into this. Picture this. A student sits down at their laptop, opens up their browser, types in www.youtube.com, and hits enter. Bam! Almost instantly, a page completely full of colorful video thumbnails appears. But what actually happened in that tiny fraction of a second? Well, we're going to track the hidden, high-speed journey of data from the exact moment that student hits enter to the moment the page fully loads. It's literally a digital race against time. All right, let's open up case file 1, The Detective Gets a Case. Our very first clue in this digital mystery is the URL, which stands for Uniform Resource Locator. Think of the URL as the specific destination address that our internet detective is handed at the very start of the case. It's the address of a website, familiar ones like google.com or readithmail.com. It's the human-readable clue that basically says, hey, here is where I want to go. But on its own, it's just not enough to actually get us there. Now, we need to figure out who is actually asking for this information. In network terminology, that student's computer is known as the client. The client is simply a computer that depends on another computer, the server, for specific resources. Our detective, the client, just cannot solve this case alone. The client doesn't have all those millions of YouTube videos stored locally on its own hard drive, right? It has to reach out into the vast outside world to fetch those resources. Moving right along to case file 2, finding the secret address. To translate that typed name into a real physical digital location, our detective has to hustle through a rapid-fire sequence of data flows. We're going to look at 3 immediate steps here. First, connecting to the ISP. Second, performing a DNS lookup. And third, resolving the IP address. Let's break down exactly what each of these checkpoints means for our investigation. First up, the ISP, or Internet Service Provider. Think of the ISP as a paid toll booth or a highway authority. Our detective absolutely must pass through here to reach the wider network. The ISP is just the company that provides your internet access for a monthly fee. So whether you're using Airtel, Vodafone Idea, BSNL, MTNL, or Geo, your client computer first has to route its requests through their systems just to get onto the digital highway. Okay, so we're on the highway, but we still need directions, right? Enter the DNS, or domain name system. Because here's the thing. Computers do not understand words like youtube.com or yahoo.co.in. They only understand numbers. The DNS acts like a giant, high-speed digital phone book. Our detective takes the URL, domain name, straight to the DNS, looks it up, and the DNS internally converts that human-friendly name into the hidden numerical coordinates the computer actually needs. And what exactly are those numerical coordinates? That's your IP address. This is the ultimate solved clue of our early investigation. An Internet protocol, or IP address, is a unique identification number assigned to a computer connected to a network, looking something like 172.16.254.1. This address serves 2 really important functions. It identifies the host or network interface, and it provides the exact location addressing. Boom, we finally have the exact coordinates where our target website's data lives. Now we're getting somewhere. Case file 3, navigating the global network. We kind of need to distinguish between the internet and an internet here. The internet is the open, massive, global network connecting millions of computers and networks all over the world, providing access to billions of websites. That's the Wild West our data is zooming through. But along the way, it might bypass closed-off private spaces called intranets. An intranet is a computer network used exclusively for sharing information and devices only within a single organization. But for us, our YouTube request is strictly an internet affair. Which brings us to case file 4, interrogating the server. So inside this destination building, there are a bunch of informants. Basically, these are host computers known as servers. A server controls access to hardware and software on the network and provides centralized storage. Now, there are a lot of different types of dedicated servers performing very specific tasks. You've got print servers managing printers, database servers storing data, and network servers managing all the traffic. But our detective, he walks right past them and interrogates the web server. The web server is the exact informant we need because its sole job is to deliver the requested web pages right back to our client computer. All right, we've got what we need. Case File 5, Delivering the Payload.
But how fast can our detective actually race this data back to the student? Well, that completely depends on bandwidth. Bandwidth is the capability of a transmission medium to transmit the maximum amount of data from one computer to another over a network in a given amount of time. Think of it like the width of the digital highway. A wider highway means way more data cars can drive side by side at top speed, getting that video loaded instantly.
So what exactly is the web server sending back in this payload? Usually it's a website, a collection of interlinked web pages that might provide limited services. Or if it's something massively complex like Yahoo or a large educational platform, it could be a web portal. A web portal essentially acts as a gateway to the World Wide Web, providing several different services from one single point of access. And finally, Case File 6, Connecting the Digital Dots. The client's browser unpacks the payload and boom, it renders the final visual output, a web page. A web page is a single digital page on the World Wide Web, created using HTML or hypertext markup language. This is what the student actually sees: the colors, the layout, the text, and of course, the videos. It's the direct visual result of the server's response. But on this newly loaded page, the mystery doesn't just end, it actually branches out. The page is totally filled with interactive elements. You've got hypertext, which is text connecting one page to another. You've got links, which are the web addresses used to make that connectivity happen. And you've got hyperlinks, which can pop up as text, an image, a button, or an arrow. When you click a hyperlink, you jump straight to the URL specified. Essentially, every single hyperlink on that page is just an open invitation for our detective to start a brand new case all over again. It's honestly amazing when you step back and look at the whole shebang, from the URL to the ISP to the DNS, translating into an IP address, crossing the massive global internet, interrogating the web server, and using bandwidth to deliver a beautifully formatted web page full of hyperlinks. So I'm going to leave you with this. Next time you click a link, ask yourself, how many servers, networks, and hidden systems just work together in a fraction of a second to bring the world directly to your screen? The digital detective never really rests. Thanks for joining me on this explainer, and keep asking questions.
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.